Hello and welcome to today's lesson on Newton's third law. In this lesson, we will begin by exploring the statement of Newton's third law, with the help of some examples. We will then explore practical implications of this law, such as pushing against a wall and the forces involved when sitting on a chair. We will also look at some misconceptions to do with Newton's third law. So far, you are familiar with Newton's first and second laws. You have learned that an object will remain at rest or in uniform motion unless acted upon by a force, and the acceleration of an object depends on the net force acting upon it and its mass. Building on this foundation, we can now introduce Newton's third law. Let's start by stating Newton's third law. For every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on another, the second object exerts a force of equal magnitude, but in the opposite direction on the first object. To make this clearer, consider two objects, A and B. If object A pushes object B pushes back on object A with the same amount of force, but in the opposite direction. This interaction shows that forces always come in pairs. Let's illustrate this with some real-world examples. Imagine you push against a sturdy wall. You exert a force on the wall with your hand. According to Newton's third law, the wall exerts an equal and opposite force back onto your hand. Even though the wall doesn't move because it's connected to the Earth's structure, you feel the resistance. This mutual force explains why you don't go through the wall. The force you exert is balanced by the wall's reaction force. When you sit on a chair, your body exerts a downward force due to gravity. This is essentially your weight. According to Newton's third law, the chair must exert an equal and opposite force upward to support you. This force is what prevents you from falling through the chair. If the chair didn't push back with an equal force, you would continue moving downward until you reached a surface that could. Now looking at rocket engines. They demonstrate Newton's third law on a large scale. When a rocket engine expels gas out of its thrusters, the rocket moves in the opposite direction. The expulsion of gas acts as an action force, and the rocket's movement is the reaction, propelling it upwards. Sometimes Newton's third law seems counterintuitive because we think only about one object at a time. A common misconception is thinking that if forces are equal and opposite, nothing should move. However, it's important to understand that these pairs of forces act on different objects. Movement occurs when there is an imbalance of forces acting on a single object, even though the pair itself is balanced between two objects. Another point to consider is the scale of the reaction forces. In some cases, the reaction force might be too small to notice. For instance, Earth exerts a force on you as you push against it when you walk. Although the Earth moves a tiny amount in response, this movement is imperceptible due to its massive size compared to a human. In today's lesson, we delved into Newton's third law, which states that for every action, there is an equal and opposite reaction. This principle means that whenever one object exerts a force on another, the second object exerts an equal force in the opposite direction on the first object. We explored real-world examples like pushing against a wall, sitting on a chair, walking, and rocket propulsion to illustrate this concept. We also addressed common misconceptions, such as the belief that equal and opposite forces imply no movement, clarifying that these forces act on different objects. Furthermore, we discussed how the scale of reaction forces can sometimes make them imperceptible. Overall, understanding Newton's third law deepens our comprehension of force interactions and the balance they create in everyday phenomena. Watch the rest of the GCSE physics course at Sophos Education.